Hello everyone! In this video, I will try to give you an intuitive understanding of the LangChain Expression Language and the concept of chains. So first, what is a chain? A chain refers to a sequence of tasks where the output of one task is the input of the following task. How do we create a chain? We create chains using the LangChain Expression Language, or LCEL for short. When I first heard about LCEL, I thought it was a whole new programming language that I had to learn. But that's not the case at all. LCEL is a syntax that's based only on two concepts, Runnables and the pipe operator. If you understand these two concepts, you understand LCEL. So let's consider two tasks chained together. In LCEL, each task is an object called a runnable, and the link between them is the pipe operator represented by this symbol. A runnable is basically a function with a wrapper that gives it the ability to be chained. Many LangChain components implement the Runnable protocol, including chat models, LLMs, retrievers, prompt templates, and more. However, you can also make any custom function a runnable and chain it with other runnables. Now, what is the pipe operator? Basically, when we use the pipe operator like this, it takes the output of A and passes it as the input to B. So in summary, runnable is a function wrapped to be chainable, and the pipe operator passes the output of one runnable to the next. Alright, so now that you've got the intuition behind LCEL, let's do a demo to see how you can create different types of chains using runnables. First, I will start by loading environment variables where I have my OpenAI API key. And then let's start with a classic example of a chain that takes user input, creates a prompt, and gives the prompt to the model, which will generate an output. First, we create a model instance using OpenAI and this GPT model, and then I have this template that says, explain this concept to me in one sentence, here is the concept. And from this template, we create prompts. And then the prompt and the model are runnables connected by the pipe operator. And we can run the resulting chain using the invoke method. If we print the result, we get this text explaining what is a large language model. So now we have seen how to create a chain from prompt and model, which are LangChain components that implement the Runnable protocol. Now let's see how we can create a custom runnable. Let's take, for example, this simple function convert to uppercase that converts a string to uppercase. If we want to add it as a step in our chain, we need to convert it to a runnable. And to do that, we simply wrap it using this Runnable Lambda class that we import from LangChain core runnables. And then we can create a new chain with the previous chain followed by our custom runnable. And if we do chain1.invoke and we give it the input hello, it should perform all the steps of chain1. So it should create the prompt that says explain the concept of hello, give this prompt to the model and get the explanation, then pass the explanation to our custom runnable and convert it to uppercase. Let's run and see. And here, that's exactly what we get. Explanation of hello in uppercase. So that's it. This is how you create a custom runnable. Now, let's say you want to create a chain that requires two inputs, question and context that you want to retrieve from some vector store where you have your data. Then you use the question and the context to create the prompt, and you pass the prompt to the model. The way you pass multiple inputs to a chain is using a dictionary. So before the prompt, you would add a step like this with your inputs being the elements of the dictionary. But you might be wondering, didn't we say that we need to have only runnable objects in the chain? Well, actually, you can wrap this dictionary using a runnable class called RunnableParallel. But even if you don't do it explicitly, LangChain interprets the dictionary as a runnable. Now, the user only gives the question. How do we get the context? We can get the context from our data in the vector store using the retriever component. And how do we get the question? Well, the question is exactly the user input, so we can get it without doing anything. And there is a runnable that does nothing, and it's called a runnable pass-through. So in the code, we start by creating our components. So we create a vector store with some example data. We create the retriever, the prompt, and the model. And our chain that we call a retrieval chain looks like this, starting with our dictionary, then the prompt and the model. And we also add this output parser to format our output correctly. And if we do retrieval chain.invoke and we pass the input question, we get our results. So now we have seen how to create a chain with multiple inputs using a runnable pass-through and formatting our inputs in a dictionary that will be interpreted as a runnable parallel. It turns out that the runnable parallel has other use cases as well. For example, we can use it to run multiple chains concurrently. For example, let's say we have two chains, a joke chain with a prompt that says, "Tell me a joke about a topic," and a poem chain that says, "Write a two-line poem about a topic." We can wrap these two chains using a runnable parallel and create one chain that we can call map chain. And if we do map chain.invoke and we pass a topic, it runs both chains and gives both outputs. To understand why this is interesting, let's try to run each chain separately and compare. So as we can see, running chains separately takes more time than running them concurrently using runnable parallel. Alright, now let's recap what we learned in this demo. First, we created an example chain using LangChain components. Then we learned how we can create custom runnable using runnable lambda. Then we created a multiple input chain using dictionary and runnable pass-through. And finally, we learned how we can run chains concurrently using runnable parallel.